Hello, in this video we're going to learn about multiplying and dividing rational expressions. To get us into the right frame of mind and thinking about the most basic things that we're doing in this process, I have some easy problems here. 10 over 14 times 49 over 15. What I don't want you to do is multiply the top numbers together and then multiply the bottom numbers together and then reduce from there, because these numbers are very large and we would rather work with smaller numbers. So please don't be doing it like that. As we know from last video, we want to factor first, thus Frez red. We're going to factor, and so the top left fraction should be 2 times 5, the bottom left is 2 times 7, and then the top right is 7 times 7, and the bottom right is 3 times 5. Now once we've factored everything, it doesn't really matter which fraction these are in. I mean, if I wanted to, I could just combine these, right, and put multiplication signs, because when you're multiplying, it's just top times top over bottom times bottom. So now I can reduce things. I can reduce those and those. I can get rid of the 5 and the 5. And so what we're left with is 7 over 3. And so that can be our final answer. Now in this case there's nothing to restrict because there's no variables in the bottom. Let's take a look at the green one over here. You'll remember from back in the day that to divide fractions you just multiply by the reciprocal of the second one. And just like the blue problem previously, we're going to factor. So we get 3 times 7, and the bottom looks like 2 times 2 times 2. And again, it doesn't really matter which fraction they're in, so I'll just put them all together. Now we can reduce this 2 and that 2, 7, 7, and so I'm going to end up with 3 over 4. Easy. Now let's go on to another one. Let's take a look at the green one first. In this case, we're going to factor, so I have 2 and x on the top left. I have 5x times x. I'll just put x squared to save room. On top right I have 3 times 5 times x cubed, and on the bottom I have 2 times 2. Alright, time to restrict now. So on the bottom we have a factor that is x. We actually have 2 of them, but since they're the same it doesn't matter. We can just say x cannot be 0. And now we can go on to our reduction phase. So this 2 can go with that 2. This 5 reduces that 5. 2 of these x's, get rid of 2 of these x's, leaving 1, so I can just get rid of the exponent entirely, because an x by itself means x to the first. And then, so nothing matches up with the 3 or the x, so we end up with x times 3 times x. So 3x squared on top and a 2 on the bottom and a restriction. Okay, so a lot of the problems that we're going to be working on in this chapter have restrictions. From this point on, you do not have to show restrictions unless specifically asked for. So for instance, in tomorrow's classwork, the instructions are multiply. That's it. So you don't need to say the restrictions. Okay. Let's move on to this blue one here. So first thing we're going to want to do is factor. So now we're just fretting, right? Fred, because no restrictions. So factoring m minus 2, there is none. Same with m plus 2, there is no factor. No factor in any of these. Okay, so then we go to the reduce part. There's nothing that matches an m minus 2 on the bottom, and there's nothing that matches an m on the bottom. Remember, the fact that this is an m and this is an m, it doesn't mean we're allowed to reduce it, because this m on the bottom is not a factor. It's actually a term, because it's not being multiplied to -1. It's negative, or 1 is being subtracted from it. Okay, so it only becomes a factor if it's being multiplied to something, and everything has to be multiplied. It can't. Some things can't be multiplied, and then other things are being added. So in this case, there is nothing to reduce. So the actual answer is so ridiculously simple that I feel most of you wouldn't even get it. all you do is smush them together accordion style. Now, you could argue that if I tell you to multiply, that you would just do the distributive property, and you would be correct. However, I won't require it on these style problems, so save time and just leave it as such. Okay, moving on. Let's get a little more complicated here. A little more complicated, a little more fun. So the top left is already factored. I'll just write it down. Bottom left can be factored as 3 times m plus 3. The top right can be factored as 2 times m plus 3. And the bottom left can be 2 times m minus 2. Now we have all factors. Okay, notice m minus 2 is a factor, 2 is a factor, m plus 3 is a factor. So all these things are being multiplied. So I can just, do that. So m minus 2 can factor or can reduce with the m minus 2 on the bottom. M plus 3 can go away. This 2 and this 2 can go away, leaving nothing on top. Well, not nothing. It's actually 1, right? Because technically, although I don't write them often, when you factor something out or when you reduce something fractionally, it leaves a 1 in its place. But I don't always put them there. So on the bottom, just a 3. So 1/3 would be the answer to that. Again, we don't have to restrict because it's not asked for in this case. All right, let's get on to some division. This looks complicated and hard, but it's actually really simple and quick as long as you know you're factoring well. So we need to flip this second fraction. What I'll do is I'll flip it and factor it kind of in the same step to save space here. So top left factoring is going to be factors of 8 are 4 and 2, and those also add to 6. Bottom left, we can get 2 and negative 1, so x plus 2, x minus 1. Now these flip, so the 2x plus 4 actually becomes the top, and then I'll factor it like so, and then the bottom stays as x plus 4. Okay, now everything's a factor. Once they're in parentheses, or all by themselves, effectively in parentheses, the whole thing is the factor, not a part of it. So x here is not a factor. X plus 4 is. Alright, so I'm going to get rid of x plus 4. I'm going to get rid of x plus 2. So that leaves, we have 2 times x plus 2 on the top, and just an x minus 1 on the bottom. Now when it's all alone by itself, you don't have to put parentheses there. Alright, so again, you could write 2x plus 4 on the top, but you don't have to do that, so to save time, don't worry about it. Let's go to one last one. This looks complicated, but it's actually just as simple as the last one. What you do, we have 2 divisions here, because a fraction bar is a division, right? Just like we have here, we actually have 3. We have this fraction bar, and this division symbol. Here we actually have 2. So what you can do is use the big fraction bar as a division symbol. So you can rewrite this to look like t squared minus t minus 6 divided by t minus 3 over t plus 2. Now it's starting to look more like this last problem, which wasn't bad. The one thing that'll make it even more similar to the last problem is just put that over 1. So again, use that big fraction bar as this division sign. So this fraction bar has become this division sign. And I just put this over 1, so it makes it a fraction. So I'm going to do the same thing. Fred, factoring. So factors of negative 6 would be t minus 3 and t plus 2. Those add to negative 1 over 1. Now I'm going to flip this second fraction, so t plus 2 ends up on the top, and t minus 3 ends up on the bottom. We're all factored. Now we're reducing, so t minus 3 goes away, leaving us with t plus 2 times t plus 2. We can just write t plus 2 squared. We don't need the over 1, because anything divided by 1 doesn't change it, right? So we're all set. That's it for this video. Thanks for watching.